Good afternoon again to all participants. Welcome to this session on Caribbean groundwater. It's a true pleasure to be here and to discuss this important issue on groundwater in the Caribbean. We are gathering at this auspicious occasion of the World Water Day 2022. My name is Jean-Paul Ngomabiaga. I'm the program coordinator for the Natural and the Ocean Sciences in the Caribbean, based in Jamaica, but I'm live from Dakar for the World Water Forum. I'm pleased to welcome the panelists of today's session. First of all, welcome to Dr. Sarah Jade Govia, who works for the Caribbean Water and Wastewater Association. Welcome also to Enrique Chavez, who is part of the working group on the Groundwater Resources Assessment Project under the effects of human activity and climate change. Welcome to Dr. Denroy Ballantyne with IHP focal point in St. Vincent and the Grenadines. We also have two more panelists, Dr. John Bowley from the Bahamas with the IHP focal point, and also Dr. Filomeno Marchena with the UNESCO Chair in Technology and Sustainable Water Management in Curacao. So let's start this session because we are here to make visible the invisible, which is the theme of this World Water Day, when we know that groundwater accounts for 99% of all liquid fresh water on Earth. It's a resource that seems to be hugely available, but which is fragile and which is unfairly distributed. And that's what we are going to see today with our four panelists. Without further ado, let me give the floor to Sarah Jade Govia for the Caribbean Water and Wastewater Association. Thank you very much.
Thank you very much, John Paul, and hello everyone from Trinidad and Tobago. I am the president of the Caribbean Water and Wastewater Association, and we are a regional grouping of professionals, utilities, and corporate entities that work in the water and sanitation, as well as the solid waste space in the Caribbean. And we have a lot of experience in advocating for better management of water in general. So we're very happy to once again with UNESCO IHP for this World Water Day celebration of Caribbean groundwaters in particular. And my very short presentation today is going to make the link between groundwater and Caribbean water security from the perspective of the professionals at the CWWA and what we have seen. Groundwater in the Caribbean is a source of water for primary source of water for many Caribbean states. And we see from the pie chart, as reflected in the pie chart on this slide, that 52% of groundwater, of water sources in the Caribbean are from groundwater. And that means that a lot of our Caribbean states are heavily dependent on groundwater for supply. In particular, countries, small islands such as Barbados, Bahamas, Antigua, and Barbados, some of those countries that primarily use groundwater. Of course, surface water is coming up next at 35%, and then 12% of the total water that is used in the region comes from desalination. And this is significant because groundwater, while it is definitely at risk, it is also a risk mitigation strategy when it comes to water supply, because groundwater can localize sources of supply in comparison to surface water systems that usually feed a more extensive area. Groundwater wells can feed one particular community. So you have less risk and less cost involved in transmission and distribution of that water. Groundwater is also not immediately prone to contamination. And I say not immediately because it is definitely at risk for contamination, but because of the process of infiltration and percolation through the ground, it is at less risk than surface water, which is directly impacted by any sort of contaminant or pollution event. And then what we find is that in a lot of Caribbean countries, groundwater is a source of supply when the dry season hits. And for most of our Caribbean islands, all of them, they experience 2 seasons, a wet and a dry, and that really is just dependent on the frequency of rainfall. So groundwater comes in to buffer that shortage of rainfall that occurs during the dry season, and that's impacted by reduced river levels. So groundwater comes in to augment that supply. But there are significant threats to groundwater in the Caribbean. And one of the first threats is the issue of land use and planning and how it impacts groundwater recharge. And oftentimes what you find is that land use and planning in the Caribbean is not done to protect or conserve water resources or to conserve and protect the water environment. And that is a watershed from which all water originates and flows to. And because of this lack of land use and planning for water resources, you tend to find that areas that are groundwater recharge zones, development in those areas are not made particular to allow for continued recharge of those groundwater zones. Contamination is also a major issue for groundwater in the Caribbean, particularly when wastewater treatment facilities, particularly on-lot systems, are sited in places that are not prone to contamination or prone to seepage into these aquifer systems. Agriculture also is another source of contamination. And then we also have something very common in the Caribbean, and that is the risk of cemeteries contaminating groundwater. One of the very common threats to groundwater is the issue of saltwater intrusion or salinization. And this tends to happen when there is over-abstraction of groundwater. So when the abstraction of water from that particular aquifer, from that particular well field exceeds the recharge rate. And perhaps what is at the crossroads of all of these threats is the fact that we have insufficient management instruments, insufficient data and assessment of groundwater that is resulting in or exacerbating a lot of these issues that we're having. So our capacity to model, our capacity to collect data and analyze data for management of groundwater needs a lot of improvement. And then finally, our existential crisis that is affecting groundwater, and that is climate. And what we're seeing is because of climate change, the impacts to groundwater are very extreme. So we have reduced recharge and in a lot of cases, irreversible intrusion of the aquifers by saltwater. So climate change is only going to exacerbate all these issues as we move forward. So in the Caribbean Water and Wastewater Association, we have seen these challenges, and in 2019, we developed a regional strategic action plan for governance and building resiliency in the water sector to climate change. And we call that, the shortened name for that is the RSAP. And we have, between 2019 to 2021, we've developed several implementation plans to implement that action. And a couple of the topics that we have focused on for groundwater is quantification of water resources. We recognize that a lot of Caribbean states can benefit from a master planning exercise that would involve assessing the quantity and quality of freshwater resources, and then aligning that to what is the future demand for water. Another activity that we have on the table is modeling of groundwater resources and the impacts on climate change of those water resources. And then finally, something that is not well understood in the region, and that is the hydrological connection between ground and surface water. And this is significant because a lot of the times we use groundwater, as you see, 52%, we use groundwater as a means of augmenting surface water supply. But the connection between abstracting that groundwater and how it is going to affect surface hydrology is something which we really don't understand. So the CWWA, along with its partners, have recognized this, and we have mapped out these 3 priorities for the region in getting us closer to resiliency for groundwater resources. And these are not undertaken by CWWA alone, they're undertaken through regional collaboration with several partners. And as I close, one of the things that we are immediately launching, the CWWA, is a facility to plug the capacity gaps that we recognize exist relative in particular to groundwater. And we have launched the CWWA Regional Education Foundation, and we're calling it REEF, which is a virtual rich reef network for research and learning in the water and wastewater sector. So this is a platform from which all the training that the CWWA typically offers is going to fall under not just training, but also research, because we recognize that there's a lot of work to do in plugging the gap between research and industry. So our regional groundwater management training is going to take place in April, and it's open for anyone, including professionals that do not necessarily operate in the water space, but would love to get more knowledge on groundwater. So it's a 3-day, 3-hour session that's going to be undertaken in collaboration with CAPNet. And we're going to be covering topics such as integrated water resources management and how it impacts groundwater, the groundwater enabling environment, the legislation and policies that are typical of the region, and drafting those type of instruments, as well as looking at groundwater abstraction and regulation of that abstraction, both for the private abstractors as well as at the utility scale. And then finally, looking at groundwater management tools and groundwater quality management. So as we move on and we continue to celebrate World Water Day, the CWWA looks forward to your participation in our training sessions. And thank you once again, UNESCO IHP, for inviting us.
Thank you very much, Sarah Jed. It was great hearing you about the groundwater dependence and the threats that lie on them. So you've mentioned the different challenges that the region is facing, namely vis-a-vis of climate change and salination and different other consequences. This gives me a wonderful transition to Dr. John Boleg, who will talk about the situation, maybe specifically in the Bahamas. And we all know that Hurricane Dorian in 2019 faced the country and caused a lot of salination of groundwaters. Dr. Boleg, the floor is yours.
Okay. Yes, thank you for having me. I'm going to bring up the presentation and share the screen. If you give me just a chance. Okay, you can't see my screen yet, correct? My apologies here. Okay. Okay. Can you see my screen? Correct? Okay.
Yes, all good.
Thank you. And it's good to join you today for International Groundwater Day. Apologies for jumping on late. Nonetheless, I'm here to join you. In the Bahamas, we only rely on groundwater. Groundwater is the only source of fresh water that we do have in the Bahamas. So groundwater is extremely important to us. Groundwater is, as I said, our only source of water. So we have had to adapt to the shortage of water because in the Bahamas, we have no true rivers, lakes, or streams. So we are totally groundwater dependent. And thus we have moved to dependence on reverse osmosis desalination for required fresh water. Pardon me. I'm having some technical difficulties here. Sorry. Okay, I will just continue on until I get this all sorted out. So in the Bahamas, as I said again, so what we're doing in the Bahamas as far as our groundwater is concerned is that due to climate change, our dependence on the groundwater resources has always been impacted due to the various hurricanes and storms that have passed through the Bahamas. But that nonetheless, we've turned to other technologies to provide fresh water, one being reverse osmosis. Additionally, with our groundwater, the groundwater is all by means of rainfall, and it's basically just sitting on top of the saltwater lens. So the same saltwater lens is the exact water that's out at the coastal zone. And what we have found is that due to our dependence on the lens, we've done extensive research, and we've discovered the inverted geothermal conditions of the groundwater lens. So we are able to utilize the groundwater resources for seawater district cooling. The deeper we go, the cooler the water gets. So that is one of the benefits in the Bahamas, and the ability to use these groundwater resources for other means and adapting to the various needs of the islands of the Bahamas. What we're presently engaged in that's very exciting for the groundwater resources is utilizing the same reverse geothermal conditions for the possibility of ocean thermal energy conversion. And this is something that we are very eager on developing in the Bahamas. We feel that utilization of our groundwater resources sets us apart due to these inverted geothermal conditions. And we are by all means exploring all efforts to bring ocean thermal energy conversion to the Bahamas. What it does is it helps us, as we have, as a mitigation strategy to climate change, we have had to turn to reverse osmosis. So by going to reverse osmosis, essentially that process requires a great deal of energy. And we do think that for climate resilience purposes, if we can also address the energy by use of the groundwater resources and pairing these technologies together, it would be much more beneficial for the Bahamas. So we're looking at pairing ocean thermal energy conversion, utilizing that same water that we're presently using for the seawater reverse osmosis process, since it's a very cool source, bringing that water up, utilizing it also with the 20°C differential, just for small OTEC purposes, initially to run the various distribution pumps, the various pumping mechanisms that are required for pumping water throughout the communities with distribution pumps, and also the various pumps that are required for the reverse osmosis process. So this here is by pairing the various technologies together, we one day hope to transition to a stage where these wells, these groundwater wells, can be utilized, all saltwater purposes, where we utilize the same source for seawater reverse osmosis. We utilize that same source, cool water supply for seawater district cooling, seawater AC, and additionally, as an energy component, we utilize it for ocean thermal energy conversion. Apologies that I have not been able to get these presentations, but hopefully I've got my point across to you. And by all means, UNESCO will be provided with a presentation, but it's just to let you know that in the face of a changing climate, we're looking at all resources and turning our view to the ocean for energy, and by doing so, turning our view to the groundwater in the Bahamas for energy, for fresh water, and for cooling purposes. So groundwater, again, is very important to us in the Bahamas, and we are doing all that we can to ensure that we are very resilient with the use of our groundwater resources, and also ensuring that we do preserve what other fresh water, which small resources of fresh water we do have from groundwater. And I do see that we're joined here with today with the head of the graphic program, and I'm certain that he will be explaining other things and other methods that we are also employing throughout the Bahamas, hopefully, and just other mechanisms for conservation of groundwater and how we can best utilize these resources that are very finite, so very important to us in the Bahamas and other small island development states. So thank you again, and happy World Water Day 2022 to all. Thank you.
Thank you very much, John, for your presentation. Even without the slide, it was truly interesting, and we all understood the challenges and the different solutions that Bahamas is turning to vis-a-vis of the water resources that can be made available, namely through the ocean. So it's very clear that the region is a region that is namely affected by climate change, its impacts, but also to natural disasters, as we have seen it last year, for example, with the volcanic eruption that happened in St. Vincent and the Grenadines. This gives me the occasion to give the floor to Denroy Ballantyne for his presentation on the situation in St. Vincent and the Grenadines and its takeaway message. Thank you very much. Denroy, we can't hear you. It seems that Denroy is not ready, so I will give the floor to Enrique Chavez, who, by the way, was one of the members of the team that conducted an assessment, if I remember correctly, in St. Vincent and the Grenadines, vis-a-vis of the consequences of the volcanic eruption of last year. Enrique, would you like to speak? Thank you.
Thank you, Jean-Paul, and let me get my presentation here. I hope you can see the presentation.
Yes, it works.
Okay, well, good afternoon, everyone. I see here many colleagues that we have worked in the recent years with the graphic project. For those of you who don't know me, Professor Enrique Chavez, Professor of Watershed Management, University of Brasilia, and presently the coordinator of the Graphic Latin American Caribbean project. And our talk this afternoon on this issue of groundwater making the invisible visible is about the Graphic project and its disaster adaptation initiatives in the Bahamas and St. Vincent, which are the two islands that we have worked recently in two very important disasters, natural disasters that affected those two islands, namely the Grand Bahama in the Bahamas, due to the Hurricane Dorian in 2019, and more recently in St. Vincent with the explosion of the La Sofia volcano, which also created many impacts to that small island in the Caribbean. So Graphic project, the vision is to promote and advance sustainable groundwater management considering projected climate change and linked human effects, and those include, say, natural disasters such as the one that we have nominated. And its mission is to provide a platform for exchange of information through case studies, thematic working groups, scientific research, communication, etc. And in this case, we use this kind of a South-South cooperation within Graphic, the Graphic community, to provide our Caribbean colleagues with some insights regarding their water security and adaptation type initiatives in both islands that I have mentioned. Okay, what happened very briefly in those two islands? And we have the representatives of those islands here, Mr. John Bowleg and Mr. Denroy Ballantyne, the first from the Bahamas and the second from St. Vincent, who's accompanying us and could provide some more details about what happened in those particular islands recently. On the left, we have the storm surge going over the Grand Bahama Island. And you can see by the island outline that more than 50 or 60% of the island was covered by seawater during that particular event of Dorian in 2019. So you can see here in this picture below, I'm pointing at this dent caused by floating logs in the spine land. So you could see that the storm surge reached up to 3 meters high in this particular regions, which are actually the well fields of the city of Freeport, which is a major city in the Bahamas. On the right, we have the explosion of the La Sofia volcano with a lot of ash being deposited in many of the water supply systems in the island, affecting the water supply, as in the case, as opposed to in the case of Dorian, that salinized the aquifer systems in the island. Here we had the deposition of ash in the surface water systems, affecting again the water supply in a different way. Both are very severe type disasters. Eventually they are continuing type disasters, because we understood and we understand that Grand Bahama had several hurricanes similar or equivalent to Dorian. And of course, in the case of St. Vincent, it's not the first or probably not the last explosion of the La Sofia volcano. So our attempts here would be to looking at activities that would provide both the Bahamas and St. Vincent with some disaster adaptation type mechanisms to reduce the impacts and improve water security and resilience in those islands. In the case of Grand Bahama, as John Bolak mentioned, there's no river, so the groundwater is the only resource. And if groundwater is salinized, as it was in the case of Dorian 3 years ago, the idea is to how do we manage, these aquifer systems and well fields to provide at least some resilience and supply to the population. In the case of St. Vincent, although groundwater exists, it's not being used as a backup or as a supplementary system for the island. So the idea was pretty much to, in the case of St. Vincent, to evaluate the potential of groundwater supply as a backup or as a secondary system to increase the resiliency of water supply, particularly during storms, severe storms, because of surface water would be, hindered, or, the water quality would suffer during storms. And in the case of the volcano explosion also. So the idea would be in both cases to provide some assessments, evaluation of the potential, identification, adaptation measures, and also cooperating with the existing agencies in both islands. These are some of the results. These are still ongoing studies, by the way. So we, in Grand Bahama, we did an evaluation of the well field potential, looking at the freshwater lands. This is more or less a modeling type exercise in both quantity, groundwater recharge, turnover type rates, and so on, sustainable yields and so forth. And also here in the bottom, we had this mapping of the salinity of the wells after Dorian. And you can see that the largest well field to the right here, W6, was severely salinized after Dorian, and W1, which is the one in the center, less salinized, and the least salinized was W3. So water had to be used after Dorian, pretty much from W3 and some W1. And today in W6, which is at the right, they're using RO systems to get rid of the salt. And since that is the major well field in the island. So in the case of St. Vincent, we looked at the potential of groundwater across the island. We have, several aquifer systems, but we also looked at the safe yields of those aquifer systems, since they would, eventually provide backup systems to the main villages and cities in the island. So one way of assessing the safe yield was looking at the watersheds Q95. And we obtained those Q95s for many watersheds, which would be associated with these different aquifers, being as a proxy for safe yield, since though they don't exist at this moment. And also, as far as water quality is concerned, we looked at the dynamics of groundwater in different wells across the island. So the next steps of our strategy in Grand Bahama will be the mapping of the salinity levels of Freeport well fields, predicting the groundwater salinity in the next 5 years, evaluating the level of groundwater contamination by 70 water quality parameters. So this is probably unprecedented in the Bahamas, since we collected about 25 samples and brought to Brazil, and we are analyzing. Actually, we finished the analysis of those parameters, and we are in the process of writing the report and looking at metals, nitrates, and all organic, inorganic, and metallic type parameters, which would give, this particular island a lot of information for present and future groundwater management. Identification and adaptation strategies to improve water security in the island. In the case of St. Vincent, we looked at the groundwater potential of the island, looking at the wells that exist there, and also looking at the well logs and the safe fields. Evaluation of the techno-economic feasibility of the establishment of groundwater supply backup systems to, villages that are very close to the volcano proper, which would definitely require this kind of systems in order to, to decrease, risk, particularly after explosions, and the preparation of a water security project for the UN Climate Adaptation Fund, which is ongoing. And with this, I thank you for your attention, and we'll be open for questions.
Thank you very much, Enrique, for your presentation and for these two practical case studies on St. Vincent and the Grenadines and the Bahamas, and on their responses, on the potential response to climate and natural disaster. So now I think that Denroy is ready for his presentation. Denroy, the floor is yours.
Okay, thank you very much, and thank UNESCO IHP for inviting us to this World Water Day presentation. I will share my screen. I'm not too certain what's going on here with my screen. Okay. All right, I'm going to start from the beginning. So I had captioned my presentation this afternoon on changing from the visible to the invisible in St. Vincent and the Grenadines. And for persons who might not know me, I'm Denroy Ballantyne, the IHP focal point for St. Vincent, and also the head of the Water Resource Department in St. Vincent. And the demographic of St. Vincent, well, that's our location. We have a population of 110,000, and our dry season spans from December 1st to May 31st, and the wet season from June 30th to November. And that's the location of St. Vincent. Presently, as presented earlier, St. Vincent is dependent on surface water, and I have quotes from Dr. Cashmont, which states that many of the islands, including Trinidad and Tobago, Grenada, St. Vincent, and the Grenadines, St. Lucia, Dominica, and others, predominantly use surface water for their water supplies. The volume of water stored per person in St. Vincent is 45 meter cube, and the total production for 2020 was 2.1 billion imperial gallons. And the statement, fresh water is finite and vulnerable. And for us in St. Vincent and the Grenadines, we can attest to this fact. So far, we have 11 water intakes on mainland St. Vincent. All of our systems are gravity fed and the Grenadines are dependent on rainwater harvesting and horn dog wells. Our surface water are impacted by climate variability and change. And so in the dry season, we have significant impacts. We have reduction in the rainfall. Therefore, we have a reduction in our surface water and the surface discharge. Heavy rainfall intensities will affect our surface water, resulting in deteriorating water quality and surface runoffs, which contaminates the water. And we have also landslide and non-slippage, which increases sediment loads and turbidity levels in our water supply. And therefore, the water quality is significantly impacted on. As John mentioned, we are in the hurricane path, and therefore tropical cyclones are affecting the infrastructure, the property, the health, the agriculture, loss of lives, and displaced population. Tropical cyclones impact our water supply significantly because we have damaged infrastructure in recent times. And also in this, I think I missed volcanic eruption, but I will come to that later. Human activities also will affect it, and we are on a reforestation drive presently because of the volcanic eruption, which destroys just about 75% of our forest and wildlife. We have also rapid urbanization and human intervention. And human intervention, especially during this month, we are expecting to have river poisoning, and that's a traditional event where the local population would actually look for freshwater fish. All right, and as I mentioned earlier, we have climate variation, and what has happened and what we have noticed in 2021 is that our rainfall pattern has changed. In 2021, we have a reduction in rainfall, and in St. Vincent, we said that this is a deficit year because our major water supply, which is the Galloway water supply, which is the deep blue, which supplies 45% of our water. In 2021, we noticed that we have a reduction in the rainfall at that intake, and therefore that would have affected the water supply. And in addition to that, the systems throughout St. Vincent would have been affected. All right. And from this intake also, we notice there's a trend line that there has been a reduction in the total rainfall. Now, our water supply is surface water, as I mentioned, and so recharge is quite important for us. And if this is a rainfall reduction in November in St. Vincent, the wet month or the wettest of the year is actually November. So November, we have noticed that there has been a deficit, all right, in some intakes, especially in the Galloway intake, so it supplies 45% of our customer base. We have a reduction of 35.49%. It is the effect of natural disasters, and we have the volcanic eruption, and this is just a photo of what has taken place. The suspended ash particles in the atmosphere. Also, this is a dry period in 2019 where one of our intakes went dry. And this is a volcanic relief where we use groundwater to supply supply the entire country at this point. Because of the volcanic eruption, we would have tapped into our well. Well, this well is actually south of the island, and it's actually we would have tested the quality, and it's quite potable for drinking purpose. And this is flooding event after the volcanic eruption. We would have had lahars coming down and actually affecting the road infrastructure, houses, and other amenities. All right. This is the water quality before and after the volcanic eruption. Before the volcanic eruption, we would have had crystal clear water with NTUs less than 1. After the eruption, which is this photo, it's actually turned brown, whitish in coloration, and then the NTUs would have increased significantly, and therefore we have to flush the entire system. This water was tested by with assistance from CWWA, water missions, and other partners in the Caribbean, so that we can verify the water quality at that point. And then we go, that was the visible, and then we go to the invisible. And with the invisible, as my colleague from DC WWA mentioned, that I'm not going to repeat much, but these are the islands that are supplied by groundwater. And these are the advantages of groundwater against surface water. And what we are doing here, as my colleague just mentioned, that the advantages of us moving from groundwater is pretty huge, because as I mentioned previously, our surface water are easily contaminated by natural disasters, and as I mentioned some previously, hurricane and volcanic, and therefore we have to look for a more stable water supply for our customers. All right, this is one of the wells that Enrique mentioned that we are looking at, and it's north of the island. It's within the red zone. But what is happening in that area is that the surface water are easily contaminated, especially after the volcanic eruption, where there are lahars and other contaminants, so it's easily flooded. All of our infrastructures are easily destroyed, and therefore they are presently temporary structures instead of permanent, because once we replace in a matter of an intense rainfall period, it is back to the normal situation where it's all washed away and destroyed. So we are actually exploring the possibility of groundwater north of the island with extension to south of the island. This is a pilot project. It's a project that will be using renewable energies for power generation. The objective of this is to have an average demand of 24 meter cube per hour, which is 126 gallons per day. We're looking at a pump head of 125 meters, a pump rate of just about 72 meter cube per hour. And the proposed pump depth is actually 20 meters. Our team from UNESCO IHP visited, and they would have tested the quality, and it's quite possible, as I mentioned, and it's quite a feasible project that we are entering into. And the estimated cost of this project is just about $5.5 million. All right. As I mentioned, well, in groundwater quality, but in specific mention to this well north of the island, which is the Overland well, the turbidity levels are pretty low. The last pump test we did, they were actually less than 1 NTU, and we would have pumped it for at least 48 hours, constant rate. The nitrate content is acceptable, and we will have collect some samples and send it to the US EAP lab for water quality analysis. We will have detected no coliform, so no coliform content, and these are indicators from septic and surface sources. So, and it's quite important that we check these. We continue to monitor for specific conductivity because of its location and other physical and chemical parameters. And I thank you. I just hope that I didn't exceed my time, but just thanks and happy World Water Day to everyone. Once again, thanks to UNESCO IHP for accommodating us.
Thank you very much, Dan Roy, and thank you very much to all of you. It was a great session, and we have seen the different groundwater challenges and the threats, whether it is overexploitation, saline intrusion, contamination, pollution, but also climate change, which is one of the major challenges of the sub-region. But we have also seen the dependencies of the Caribbean island to groundwater, to this resource that is fragile and that is unfairly distributed, as we have said at the beginning of this session. All in all, I think that we have seen, you have demonstrated very well the centrality of groundwater to the Caribbean states, to human life, to food and water security. And you have also showcased many solutions and innovations that are really takeaway messages for the future. I think that to close that session, we will probably all agree that we need a better understanding of the groundwater resources in the Caribbean, the different mechanism of recharge and discharge, and how to optimize its use for long-term sustainability. That is extremely central and important, but without forgetting the extreme importance of cooperation and cooperation again in the region. I thank you very much for making it for this session. I thank you very much for making the invisible becoming visible, which is the theme of this year's World Water Day. Thank you to all, and I wish you a pleasant afternoon. Goodbye.
Okay, goodbye. Thank you very much.
Goodbye, Jean-Paul. Goodbye, everyone. Thank you very much.
Goodbye.
Thank you.
Bye,
There's
everyone.
something wrong.
Thank you.
Sorry.